Respiratory quotient RQ and respiratory exchange ratio RER are two terms used in respiratory physiology that can become quite confusing as they're often used interchangeably. They represent the same thing though, which is CO2 produced to oxygen consumed, but it's the way that they're measured that's different. Blood tests are taken for respiratory quotient, usually an arterial and a venous sample, and this represents the measurement of CO2 produced per oxygen consumed at the cellular level. Respiratory exchange ratio, though, is a measurement taken at the mouth during breathing and is a measure of CO2 exchange to oxygen in the lungs, so between blood and atmosphere. The respiratory quotient and respiratory exchange ratio should equal each other when oxygen and CO2 are constant, so it's steady state. This makes sense because the role of the lungs is to remove waste products such as CO2 and bring oxygen into the body for cellular metabolism. Interestingly, respiratory quotient is largely dependent on the fuel source used, which is dependent on our diet. For example, if you had a diet that was 100% carbohydrates and your fuel source was 100% carbohydrates, for every CO2 produced, you would expect 1 oxygen consumed, hence the ratio is 1. For protein, the ratio is 0.8, meaning that for every CO2 produced, you would expect about 1.2 oxygen consumed. For fats, it's 0.7, which again, for every 1 CO2 produced, you would expect about 1.4 oxygen consumed. This is largely dependent on our diets, as mentioned before, and in the Western diet, the ratio is usually put to 0.8. This isn't because we eat mostly proteins, it's because our diet's mostly made of carbs and fats and equals around 0.8. Contrasting this to respiratory exchange ratio, our exchange ratio can actually go above 1 because when there's other cellular metabolism, so in anaerobic metabolism or buffering within the body, where CO2 is also produced, you have to blow off this excess CO2, which will make our ratio higher than 1, meaning you could potentially have a ratio of 2 to 1 at the lungs, given that this doesn't represent cellular metabolism, this just represents exchange between our blood and the air. The example here is if you're exercising and you have lactic acid being made, the free hydrogen ions will be buffered by bicarb, becoming water and CO2, which is then blown off.